Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm here with Keegan Kirkpatrick, the founder and CEO of RedWorks Construction Technologies. I'm really excited to chat with Keegan about what RedWorks is doing to decarbonize the construction industry with their hardware that manufactures bricks on site, on demand, using dirt sourced from the construction site. This is a big deal because those bricks could replace concrete, which today is responsible for 8% of global greenhouse gas emissions. Also, another big emitter in this industry is the transportation of materials to the building site. So on-site production can eliminate that impact as well. Keegan is at least the second guest I've had whose solution was originally envisioned to support space exploration. In addition to running RedWorks, he's a partner at Space Advisors, a group that helps companies do business in the space industry. He's also an aerospace engineer who has designed and built rockets and satellites and has taken part in more than 24 flights and test firings of reusable rockets. I first met Keegan when he gave the keynote at an event hosted by Synapse and Silicon Valley Robotics this past fall. And I found his talk inspiring and insightful, and I've been really excited to chat with him ever since. So Keegan, it's really an honor to have you on the show. Thanks for joining.
Well, thanks for inviting me, Dylan.
So we're definitely going to get into RedWorks and what you're doing here on Earth, but I do want to talk about space a bit, at least, just because it's clearly a big part of your life. So your LinkedIn profile says you're the guy who never stopped wanting to be an astronaut when you grew up. I'm curious, how close have you come to achieving that goal? How close to becoming an astronaut? And what is it about space exploration that has kept you so motivated your whole career?
Well, like you said, I've been involved in around 24 test flights when I was working for Masonry Space Systems on the Mojave Air and Spaceport. And that company has since been acquired by a company called Astrobotic, which is getting ready to send payloads to the moon. And actually, some of the hardware I worked on was instrumental in that recent mission. So that's about as close to actually touching the cosmos as I've personally gotten. I've had the good fortune of being in this business on and off in one capacity or another for the last 10 years. And what's constantly just kept me motivated on to keep one leg involved in that has been just my general love of what this industry represents. Spaceflight is the most challenging, most hazardous, most perilous thing that you can really do as an engineer. And when you're someone who even stops being a bit of a wrench turner like I was, it's an industry that constantly challenges and pushes you to be the best at what you can possibly be. So from where I see, it's an industry that is not only something trying to solve really big questions about exploration and all that kind of stuff. It's something that can be very practically used to inspire and improve whatever project you're working on terra firma at any given moment. So that's what my relationship to the business has been. I got started originally as an aerospace engineer coming out of Embry-Riddle Aeronautical University, working for Marsden and doing all this test flight work and really just getting your hands dirty right at the start of your career was a big deal for me. I've also done work for composite testing of aviation components, and I've helped more companies than I care to count as a consultant for the aerospace and defense community. So this is an industry that I've always had a lot of passion for, and I don't see it as something that is divorced from whatever any other project I'm working on. It's always something where there is going to be an idea, a resource, something that's already been half dreamed up that can help to make what you're working on a reality.
In the context of climate change, I feel like at this kind of intersection of space and climate change, I sort of feel like I hear two different perspectives maybe on each end of a spectrum. One is Mars sucks, let's focus on Earth here. We don't have a plan B. The other is that humanity, and tell me if I have this wrong, but becoming a multiplanetary species is kind of the long-term solution for humanity's long-term persistence as a species. If we really mess up this planet or something catastrophic happens, we'll have other options. I'm curious to get your take on that.
First of all, both of those takes are political takes. They're not actual reflection of reality.
Okay.
Saying there is no planet B is a very necessary thing the Green Movement has to do to be able to convince politicians to stay focused on one thing that tends to be, unfortunately, a bit of an abstract, or at least it has been for a long time. I feel the persistence of extreme weather events in the last few years should hopefully be turning people's minds around about that. And as a long political goal to make life multiplanetary, while everybody who gets involved in the space business has that belief in one capacity or another, at the end of the day, businesses don't operate on a borderline religious belief that we have to make it possible for humans to exist on two worlds at the same time. We have to make it possible for a reasonable rate of return to investors. Mars is something that is the long-term goal that can make that happen, because one of the biggest customers that wants to do that is NASA. And all of the hardware and research and flight systems that go into making it possible to go to Mars are conveniently also possible to make it practical to explore resources and opportunities in and around the Earth and lunar systems. So asteroid mining, standing up bases on the moon, building out strategic depth for military assets, things of that nature are all made much easier when you have low-cost launch vehicles that can deliver very large payloads to orbit, when you have longer-term survivability systems, improved life support systems, all that fun stuff. As for, are these two ideas of space and climate change in opposition to one another, I don't believe, not only do I not believe that's true, I believe that it does not reflect, that is the exact opposite of what reality reflects. Many have often pointed about how the images of the whole Earth from the Apollo program essentially spawned the modern environmental movement in many ways. Being able to see the Earth as a single fragile object hanging in the void did a lot to inspire people to want to save this planet from its own destruction.
The Earth shot.
To say nothing of the fact that NASA is arguably the biggest government agency when it comes to tracking, reporting, and advising on the effects of climate change, in tandem with NOAA and, of course, the EPA. This is a business that has made it possible to develop both technologies that make it easier for us to live on Earth, from improved power supply systems. Hydrogen fuel cells were originally developed for the space program as part of the Apollo era, to better weather monitoring, to better atmospheric tracking. All of this feeds back into itself. And as for the future of spaceflight, everything that is being developed right now is all based around working with a non-existent supply chain. When we talk about NASA wanting to go to the moon and lunar return and build a base up there, and all the private companies that are now exploring that as a possibility for mining, they've all got to operate on the assumption that they're going to have very, very rare and infrequent supply from Earth, and have to build out supply chains that are extremely robust and efficient. Well, all the technologies that go into building that, be it from being able to source steel and other metal sources on the moon locally, to being able to stand up power supplies and solar farms that have to operate under kind of ideal conditions for very long periods of time, to construction methodologies and technologies like what RedWorks is building to make it possible to build without having to actually have anything shipped to site in the first place, all have applications on Earth to be able to make our supply chains much more efficient and much less impactful to the climate.
That's really helpful for me. It's actually there's a much more direct link than I had really had in my head. It makes me think of this thing that people often say, that constraints drive innovation or something like that.
Necessity is the mother of invention. And the way I often think of it is that when you do anything in space, you are essentially forcing yourself into a position where necessity is going to be staring you in the face.
Right.
And that breeds innovation.
Yeah, there can't be many places on Earth that have nearly the same level of kind of challenging requirements to overcome.
Absolutely.
That makes sense. So let's talk about RedWorks then, because my understanding is RedWorks is a really good example of exactly what you're talking about.
Very much so. RedWorks got started originally as part of NASA's Centennial Challenge. NASA puts these on every year. They are usually designed to farm out the technology development process to as many people as possible in universities and even people in their garages. RedWorks was firmly in the latter camp of that. We were built out of a group of people who were mainly 3D printing enthusiasts in the Palmdale, Antelope Valley area, where Northrop and Lockheed are always stomping around, and as far as I can tell, about half the U.S. solar industry seems to call home at any given time. And NASA put out a bid for how can we incorporate additive manufacturing into the development of habitats for the moon and long-term Mars. Our team put together a proposal based on the idea of 3D printing an entire habitat just from local sources of dirt, which we thought was an idea that everyone else was already going to do, and we had just come up with a unique design for a habitat that would do all this. Turned out that our construction process that we pitched was actually the really innovative thing, and we ended up getting a lot of very positive feedback from the construction industry itself. So from that, we built out a company that was designed to essentially spin off this technology that was originally derived for research that NASA was directing for space to make it possible to build construction material, masonry units, bricks and concrete replacements, essentially, completely in the field with just the dirt that was available on site.
So originally, you weren't thinking about Earth specifically. You weren't even necessarily thinking that this construction, the brick production process was the innovation.
The applications for Earth were implicit with the pitch. NASA has been very good about that really the last 10, 20 years or so, really putting the fact that this has to be something that could even theoretically have applications on Earth. So when we submitted this, we had to say this is something that could be beneficial for the construction industry on terra firma. But it was really a back of the mind idea at the time.
Mm-hmm.
And again, we assumed we weren't pitching anything new. This seemed like such an obvious solution to us that we figured other people would, frankly, a lot smarter than us would have figured it out by now. And as is often the case when you're building a company, that ended up not being any version of reality. We ended up then actually going on the technology development timeline for all that and came to figure out exactly why no one had done this before, or at least no one had successfully done this before. It's called hardware for a reason. And we'd seen other attempts with different processes of being able to get dirt to fuse together into a solid structure that could be used for building material. A lot of organizations relied heavily on lasers or sequestering carbon or some kind of advanced chemical binding process. We developed something very original using inductive heating, came up with a completely new way to be able to achieve that. And we're able to achieve heating of material at a rate that consumes significantly less energy than goes into even the production of concrete. Just to put it into terms that everyone can understand, when you make about a pound of concrete, that generates around 5.5 pounds of carbon dioxide per pound of material. If you make a pound of our material in whatever shape you want, that's going to generate around an ounce of carbon dioxide if you're pulling like from the average of the grid. If you're in like, say, Southern California during peak production, it's essentially negative. We've actually had a friend of ours who is an advisor to the company who suggested not so long ago that if you work it right, it's kind of the ultimate form of energy exporting. Just run these machines during peak production in like downtown LA around a bunch of different job sites, take all their tailings, and then you can calculate out how far you can drive these things from the site, even on a diesel burning truck, that would still have a net benefit to the emission of CO2.
Sorry, how is it net negative? I don't understand that.
Well, if you're pulling from peak production, essentially during peak production hours of solar, you're getting more energy out of the sun than you're able to put back into the grid.
I see. You have excess energy.
Right. So if you turn these machines on during that period, you're taking energy that no one else is even able to use, even if they were being as wasteful as possible, and getting a net end product out that can be used for some kind of finished good. So it's a material that can take advantage of the inherent inefficiencies in our current grid if and when we are able to improve battery storage and microgrids and all that kind of fun stuff.
But even using just average grid cleanliness, it's a massive improvement in terms of kind of greenhouse gas emissions per pound of product produced.
Right. It's nothing else out there really compares unless you're talking like direct carbon sequestering, which is an idea that gets kicked down periodically. I see at least one company a year that pitches this solution, and they can never find a way to scale the production effectively. With our process, you could make around 1,900 tons of masonry per year that would, in effect, again, if you're just talking national grid average, would be the equivalent of like planting 208 trees worth of CO2 absorption or taking an entire car's worth of carbon dioxide emission off the road. So we're talking, and this is before you even calculate in the transport CO2 costs. Again, I've been trying to find ways to disprove this because these numbers seem just devastating, but it's something like a fully loaded semi full of concrete has to burn the equivalent of like 14 pounds of carbon dioxide per mile driven. The transport of this material is absolutely devastating to the climate. And while we tend to often see that as a problem that has to be solved on like an individual user level, it is something that is supply chain wide. And if we can create something that localizes the supply chain to the build site, you are eliminating that risk from the climate entirely.
I spent a couple summers working on a concrete crew in high school, actually. And I saw you dig out for a foundation in residential construction, and then you have these truckloads of dirt that need to go somewhere. I'm not sure, are we talking about that same exact turning into materials that can then be used to build the structure? And then also there must be emissions, associated with transporting that and dealing with that and cost associated with all of that. Yeah.
It's a whole thing.
Yeah.
Excavated material is actually ideal for our process. So when you go something like 6 feet down at most, and that's if we were like in the middle of like the Orinoco drainage basin near the Amazon, where you've got a lot of organic matter on the ground, you're going to hit the same stuff that most of the world is made out of. And when you're digging a foundation, that's mainly what you're hitting. It's feldspar or just high or silica-based dirt and sand. Tends to have not a lot of organics in it. And for our process, that is the ideal material. That's what most of this planet is made out of. I know this from extensive study. We have had, I think, a couple of hundred different samples of material run through our machine at this point from every corner of the globe. And believe you me, every corner of the globe. And depending on where you are, at best, you're burning diesel fuel to move this material to some site for infill later. That site might be on site to begin with. You might have a low spot that you have to fill in later for landscaping purposes. I'm from Western Washington. That tends to be how that goes for us a lot of the time. If you're in Southern California, where I live right now, the removal of dirt actually ends up being kind of a big environmental issue to begin with, because dirt down here tends to have a lot of ag runoff in it. It's extremely fine, so once it gets airborne, it can cause particulate contaminations that can be a real problem. I personally have one person in my life who recently discovered that he had essentially, to put it bluntly, chunks of glass that had formed in his lungs from decades of breathing in this dirt. Yeah, not good. Wow. So if you can use our process, you eliminate the dirt removal cost entirely. And I've talked to a few contractors down here who tend to do commercial grade construction that they say the cost of dirt removal for all the compliance can get into the millions. It's an insane amount of money that has to go into this, on top of the expense of energy and the subsequent expense in carbon dioxide emissions to move this material to a safe location. So if we can use that, we are turning a expensive hazard into a useful build material right there in the field.
Yeah, let's talk. That's a good segue, I think, to the business model. So there's clearly an environmental impact. It sounds like a cost benefit, at least in offsetting the need to deal with the dirt removal. What will you sell and who will your customers be?
This will be a lease and lease to buy model like most construction equipment is. So if you're average Joe doing some work on your back patio, you usually go down to a major retailer and rent a piece of equipment for the day. Not that different for your average builder. They're either, if they're a big in-house company, they might be able to buy a large number of equipment that they can store for themselves in their own warehouse systems, but most folks are just leasing equipment for the job at hand. So we'll be going through a lease and lease to buy model that will be leasing this equipment to builders to be able to get these on site and start building material they need to satisfy their clients' needs. For them, this translates into a cost savings of, well, I haven't calculated this with the most recent bout of inflation, but last I checked, it was, if you got an average, say, garden size brick, just for basic reference, that's around 55 cents a unit. If you go through a wholesaler, say a quarter, if the guy owes you a favor, maybe 10 cents per unit. For our process, it shakes out, again, national grid power, not in the middle of the Sun Belt. Around a penny per unit is what they're essentially getting. So that's their big immediate cost savings. Your average builder might care about what this does for climate change, but in the field, he or she is thinking more about what is this saving me in terms of dollar amount, and they're also thinking, what is this saving me in terms of waste cost? Around, if you're doing like a custom project, say a handful of homes that are being built for a couple of marquee clients, around a third of your actual build cost is going to end up being lost just due to waste. So that's, oh, the client changed his mind or the architect changed his mind, and now what I just had to build this whole mold out for this big keystone is no longer something I can use. So I got to throw that away, and all that parts and labor is now gone. Or darn it, what we wanted from the contractor got to the site and it's broken. So we got to reorder that. Or, oh no, the longshoremen were having a strike this weekend. Now what I need can't get to site. And all of a sudden, all this equipment I paid for is just going to be sitting here along with the guys that I have to at least pay to do something to keep them around. Because if not, they're going to go to my competitor in that whole rigmarole. I was bottle fed on this industry. My dad is a Finnish carpenter who builds staircases for a living. I'm working and I help pay for college, being able to do Finnish carpentry work and remodel work and all that kind of fun stuff. I know this stuff all too well. And this is an industry that is desperate for help. And if I can do anything about that, that's a net benefit as far as I see.
So you're printing bricks. Like when I think about a foundation, what I'm familiar with, it's formed concrete poured into forms with rebar.
Mhm.
Are we talking about replacing that concrete with brick and mortar, with bricks that you're producing on site and mortar, or where would this be used in the process?
Our current machine is being built to have a print area of around 5 feet by 5 feet. So this is like tilt-up structures is the largest thing you could conceivably build initially. The advantage of 3D printing, especially on a gantry system rather than any kind of over-engineered robotic arm, is that you can make that print area as big as you need. So eventually, we'll have something that can be able to either print large single tilt-up structures for commercial grade sites, or eventually get to a point to where this thing could print conceivably an entire foundation from some type of pre-actuating arm. When we talk about bricks, we're trying to put it in very tangible terms that people will understand. But this is a 3D printing system, so whatever end material you want to come out of it is what we can make. Initially, I expect your average builder is going to be using this primarily for non-load bearing landscape architecture, facing stones, things of that nature, which tend to be pretty expensive and where a lot of your risk comes from. But long term, as we build that level of trust with more people in construction, I'm expecting this is something that is absolutely going to be used to eventually replace foundations that are printed primarily with concrete.
Very cool. Not a foundation assembled from bricks, but actually, to your point, 3D printing theoretically has no size limit, just printing the foundation on in situ.
Yeah, exactly.
Yeah, with the dirt that was excavated to make room for it.
Right.
That's pretty cool.
Yeah. And potentially also from dirt that would normally be just dumped off from other sites that are small enough to where they don't have to worry about any of the traditional dirt removal regs. If you're ever driving around LA, you'll occasionally catch a dump truck that is just dumping off a random pile of dirt from an excavation project at some random empty field. In a few spots, it looks like someone's putting in like a skate park or an BMX bike lane or something because there's just so much of these lumpy piles of junk and dropped everywhere.
Right.
And for us, that's just more potential resources for your builders.
So just from a business growth strategy standpoint, why not go straight for the big, let's print foundations? That seems like a huge market. Is it a technology challenge to get there, or is there something else?
It's not a technology challenge. It's twofold. One, it's a trust issue. The construction industry is about as conservative as any business gets. This is a very diverse group of people, and they tend to look at new pieces of technology, just from my own personal experience and market research and all this kind of thing, with suspicion that it's going to break if it ends up having to really be put in a field where it's going to be abused. So a smaller system that is being used on more low-risk material initially is mainly designed to get something out into the field that builders can work with and trust without a whole lot of risk going into, if this is something that is printing the foundation and something wrong happens with it, the whole job is screwed. Whereas if it's building facing stones and it ends up being something to where there's less risk to the contractor, building up that level of trust is very, very important for the long-term success of any business that is working in the construction industry. Secondly, building up a larger scale 3D printer is something that necessarily means more logistical burden on RedWorks, the company. And it's just going to be easier for us for an initial product to get something a bit smaller and a little bit more meant for kind of a boutique customer just out the door initially. So it's not so much a construction problem. It's not a technology problem. It's an industry culture and a internal supply chain issue.
I imagine structural materials have really strict kind of standards you have to meet in terms of compression strength and all this kind of stuff.
You'd think so.
No? Okay.
You would think so, but weirdly, no.
Okay.
There's not really a national review board or regulatory agency. There's like local building societies, some state agencies. Mainly what you have to be able to do with that material is conduct an ASTM certified destructive test and prove that your material is equivalent to something else.
Mm-hmm.
I had one builder who at one point was telling me that what's the regulator for all this? And the regulator is if the house stays standing long term.
Okay.
I don't know if that's necessarily the right way to be handling this business. I would hope that maybe long term we have some better regulations for this kind of thing. But at least in the US, it tends to be a situation to where the builder is the one who's onboarding a lot of the risk. They are, in effect, the people who have to be responsible for what's finally being built. But in other countries, the rules are a little bit different here and there. Europe is much more centralized in its regulation of the construction industry. Fortunately, we're starting work out here in Southern California, and hopefully one day we'll be able to migrate into the European market. But until then, we're keeping our eyes on kind of local market.
I guess regardless of the regulatory environment, to your point earlier about space exploration, the stakes are high. If you're building something that's holding up a building, or if you're producing a material that's holding up a building, Is there a challenge in maintaining standards and quality of the material when your input is so variable?
Not as much as we thought originally.
Okay.
When we first started exploring this years ago, we thought that this would have a higher degree of variability, or rather, myself and Paul Petros, our chief design officer, did. Susan Jennings, who's got something like 20 odd years now in the construction industry, doing everything under the sun, is also our chief geologist, was far more confident that the material would be fairly consistent across the board, so long as it was this feldspar-based sand that most of the Earth is essentially made of. We've printed material, tested it. We don't have an ASTM machine in-house at the moment, but our own hit it with a hammer and see if it breaks has been pretty encouraging about the consistency of this. We've also got some partners out at Pisces, University of Hawaii, University of Hilo in Hawaii, that have done their own testing using a different process and have found this material tends to be about residential grade concrete equivalent. To your original point about the risk that is onboarded about this for builders, from my own personal experience, there's a little story that a lot of engineers can tell you if they've got this little pinky ring on. This is an order of the engineer ring that any engineer, civil, aerospace, or whatever, will have on you. That is a tradition that goes back to the collapse of a bridge in Canada. The first of these rings were hammered out from the wreckage of this bridge, so it is said. And the original ones actually were a little bit more draconian. They had a little spike on the inside of them. And the idea was every time you put your hand down to sign contracts certifying your work, you would be reminded that this is the cost of failure. These days, it's just more of the auditory sound of when it hits the pavement. So I carry that with me and with my company. That is a culture that never really leaves you, to be aware that you have to get it right. If you're working with something that people are going to be using every day, something that people's ordinary lives are going to be affected by. And I feel that any company that is doing anything in hardware has to be just built. That is the foundation of their culture from the beginning.
I'd love to hear a little more about what the machine is actually doing with the dirt input. Is it heating it up to a certain point where it changes form, changes state, and becomes a different material? Or
Without getting into words like transient liquid phase sintering, the best way to think of it is an artificial volcano. It is heating this material up into where the smallest grains essentially vitrify and fuse all the big chunks together. And out comes a semi-molten material that is then layered down layer by layer, really not unlike a normal plastic or FDM 3D printer. Layer by layer material goes down until you have a finished product that is designed based on a CAD file. And you have something you can then be shoved out of the machine, cool off until it's cold enough to be able to pick up with your hands, or a load-bearing machine of some kind, and lay that down for a finished retaining wall or landscaping stone and eventually foundation. The advantage of our machine for an additive manufacturing perspective is that because it's not a process that uses water or any kind of liquid binding agent, the machine's output cures faster than the next layer of material can be deposited on top of that. So the weight of the material on top of it doesn't cause any deformation in the lower material. You see this with concrete 3D printing all the time. They have to plan for it a lot of the time and just sort of assume they're going to get a deformation of the material. And you can't really do overhangs or anything like that. So it's something to where there have been concrete 3D printing demos that have been very encouraging, but they are ultimately beholden to that same supply chain, and they are having to implement this technology with the assumption that they're going to get deformation and there's only going to be so many kind of shapes they can realistically do. And for a lot of construction, a straight wall is plenty. But if you're doing anything more complicated than that, you run into problems.
You are depositing layer by layer, like plastic 3D printer, like you're talking about. And each layer is kind of a mixture of molten. The smaller particulates have been heated enough that they've turned molten, and then larger particulates that are sort of bound together by that molten material.
Right. And the fun thing is we're operating at such a high temperature, I won't say which at the moment, that if there's a high metal content of the dirt that we're working with, you'll get these kind of neat ribbons of semi-processed, but it's this really cool speckled look that you get that looks a little like kind of a granite, but a technical term of the material is welded tuft. It's the same stuff the Easter Island heads are actually made out of.
What has been hard about making this machine a reality? What have been some of the big engineering challenges you've had to overcome?
Probably the biggest one for the longest time was there isn't really a mid-market supplier of induction systems. We had to do a lot of our research sourcing really cheap little induction rigs made mainly for jewelers and a lot of amateurs. And we bought these under the assumption that we would burn them out after only a few tests. Not really practical for implementation. We've since been lucky enough to be able to get an injection of capital from our friends over at JLL, their Green Tech Foundation, and that's allowed us to bring on induction rigs normally meant for the oil and gas industry. They're like normally meant for like welding gas pipelines and what have you together really quickly in the field. Beyond that, believe it or not, probably the next biggest challenge is back pressure. We're working with an aggregate material, not a liquid or a molten plastic. Getting it through this machine is a really fun challenge. Fortunately, this is a challenge that we got the team to be able to work through, and our biggest stumbling blocks we've been able to get behind us. So right now it's a question of being able to just do the last few phases of testing and be able to get the first version of this thing out for demos, which hopefully will be happening in the early next year.
I imagine building a piece of kind of somewhat precision manufacturing equipment to live at a construction site. Those two things are a little bit in conflict with each other, aren't they? Like, I'm just thinking of how...
Oh, yeah. I've told my team from day one that we need to build this thing with the assumption that someone is going to back their truck into it, and that your average builder, if it is parked anywhere near an elevated position, someone is going to use it to be able to get a leg up to get on top of a roof or something like that.
Right.
And we have to build this thing with the assumption that it is going to be abused and has to keep working no matter what. I'm lucky enough to where I've got a team that aren't just a bunch of people who've spent their days exclusively in a lab. They're all folks who've had to kick the dirt at one point or another to be able to, with their own careers. And so they know what this business requires.
And from a product design standpoint and kind of your process, do you think about those requirements really early as you're architecting and understanding how tell me a little bit about how do those things influence those kind of early design decisions? You're not actually building something to go live in a construction site today.
Well, you have to build one that you're going to kind of, the first version of the machine is going to be something you just sort of assume you're going to babysit on the first demo projects, but you design it with the assumption that whatever improvements have to be made to it to kind of leave it alone long-term are either going to be improvements you discover you need during the initial demo tests, or improvements that can be relatively simple bolt-on mods. Something as simple as a roll cage can make all the difference for something that has to be put out in the field like this. This is a business where just being able to stick a heavy chunk of steel between you and the world is not an uncommon decision when you're building something that has to be a fairly high precision machine. We talk about it being in a construction environment, but if you've ever really stopped and look at a lot of the pieces of extreme engineering that go on just in the basic aspects of supply chains, you'll find some pretty high degree precision engineering happening all over the place. You ever see what a cotton harvester looks like for its actual pieces of equipment? It's an impressive piece of tens of thousands of moving parts that all have to be just taking a beating every single day. And there are a gazillion of those things in the field. So it's a challenge, but it's not something that we are unfamiliar with, and the industry we work with is not unfamiliar with it.
What's your vision for RedWorks? What do you think the kind of the scale of the impact you could have could look like?
I want this to be something that on a basic level can be used to make construction a lot cheaper, to be able to help address the national housing shortage we have in the US. And long term, I want it to be something that can be used to build in places that don't have much of a supply chain or any kind of on-site logistics to speak of. For my money, this is something that is designed to be able to make human life not just more sustainable, but just better.
I see a lot of companies looking to make concrete production less environmentally, reduce the greenhouse gas emissions of concrete production. And you're the first person I've talked to who's really looking at replacing concrete with something better or less impactful. Do you think that this kind of approach could take a big bite out of that 8% greenhouse gas emissions we see from concrete globally?
Absolutely. And again, the emission numbers that I'm more worried about are the 20-25% that tends to come from the supply chain itself.
I see.
If we can disrupt that even a little bit, that has massive impacts on humanity's impact on the climate at large.
When do you think? What's a reasonable time frame for that?
Well, if we can get the thing out the door and being used in these early projects next year, there's going to be a ramp-up period, building out our internal supply chain. Year after that is making that supply chain a reality and getting this in the hands of a lot of kind of high-end demo customers. And then it comes down to breaking into what is traditionally known as on-spec construction. So that's going from 1 to 5 to maybe a dozen houses that are being built in some kind of really specialized project to 20 to 200 houses. That's a timeline that's probably in more like a 5 to 10 year time scale than anything else. But if we can increase production correctly, if we can get people to trust what this business means for the industry, sky's the limit.
Awesome. So I have 3 questions that I wrap every episode with. How optimistic or pessimistic are you about the future of the planet and why?
I think whatever challenge humans are facing in the moment, we will eventually figure out how to match it. It's just going to be, it's like that old Churchill quote, after we've exhausted every other option. I think that humanity will eventually find a way to address the challenge of climate change. I just think it's going to take a greater degree of coordination than we've presently seen. But I also know that we will eventually execute that degree of coordination. We've done it before. It's one of my favorite little chapters of history everyone always forgets about was the Dust Bowl, the last big climate disaster the United States really faced. You don't count the hole in the ozone layer anyway. Normally, when we talk about that in history, it just ends up, we never talk about the resolution. That was a crisis that the US government, in combination with state governments during the New Deal, was able to address by building these huge shelter belts across the Great Plains that stand to this day. And if you're from one of the Great Prairie states, you've likely seen these at one point in your life. These acted as a windbreak and also to both better sequester water and stop the wind erosion that created this dust bowl in the first place. If we could do that in the 1930s, there's no reason we couldn't solve our current problem today.
Do you think part of the solution will be multiplanetary habitation?
I would like to think so. I think that it's more of a question of technologies being developed for that effort that would have a lot of uses back here on terra firma.
Who is another company or individual doing something to address climate change that's inspiring you?
On a personal level, a fellow by the name of Jeff Lawton out there, who just Google his name and permaculture, and you'll immediately want to start doing this kind of thing in your own backyard. Lawton is a guy who probably knows more about permaculture, agriculture than any 10 people I've ever seen, who is really looking to address climate change through a combination of reforestation and what's often called afforestation, building up ecosystems in places that have never held them before. He's been doing some work around in Jordan in otherwise lifeless desert to be able to improve water retention in the ground and stand up new trees and eventually agriculture for fruit-bearing plants and all that kind of stuff. But it might not be a company approach necessarily, but it is the most hands-on, direct solution I've seen. And unlike a lot of other tree planting initiatives, it's one that's seen kind of from beginning to end. A lot of folks just do these kind of tree bombs or just planting a tree and then walking away. But they tend to do it in places where the forest is going to recover naturally on its own anyway. This is stuff that's being done in places that are totally desolated and need to have the hand of man to come in and actually repair it.
Cool. I'll look them up. What advice do you have for someone not working in climate today who wants to do something to help?
Short answer is that look to solutions outside of your own industry necessarily. Your industry has, whatever industry you're in, they probably tried to fight climate change to one degree or another for the last 30 odd years. And unfortunately, they probably don't have a lot to show for it. Looking outside the box is the most common piece of advice people are given in any industry, but that really is the best advice I can give. If you're in the construction sector, look to what NASA's doing. If you're in the biotech sector, look what's being done in commercial agriculture. Look to solutions that you would never normally think of and see if there's a way to be able to onboard those, improve those with the skills and tools you have available.
Love it. Keegan, that was awesome. Thank you. Really inspired by what you're doing. Thanks for all your time.
Well, thank you, sir. Appreciate it.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.